process for growing the oxide layer was very simple and doesn't require any additional materials. Because of that, it greatly reduced the complexity required to produce an integrated circuit. How do we actually achieve any of this in the home lab? Well, we have two different ways of growing oxide layers: the dry method and the wet method. The dry method uses oxygen from the air and reacts with silicon at high temperatures to form SiO2, or silicon dioxide. This method produces the best quality oxide layer, but has the disadvantage of being extremely slow, so it's really only suitable for very thin layers. The wet method, on the other hand, uses steam. The oxygen in the water molecules is the source of the oxygen for this reaction. The reaction also takes place at high temperatures, but it is much, much faster. For any given temperature, the wet oxidation method is around 10 times faster than the dry method. Because of that, we usually use wet oxidation for any layers greater than about 100 nanometers. We are looking to make thick oxide layers today, so this is the method we will use. The reaction that creates the silicon dioxide is happening at the silicon surface, which is initially exposed, but slowly is being buried beneath an oxide layer. In order to create more oxide, new oxygen has to penetrate the entire thickness of this existing oxide layer, and then react with the silicon to form silicon dioxide. The thicker the oxide layer, the less oxygen reaches the surface, and the slower the layer will grow. Wow, I really got carried away this time. I think it's safe to say that silicon oxidation is good to go.
First, prepare the silicon wafers to be oxidized. Take the required number of wafers and register. To ensure the sample surface is clean and avoid contaminating the oxidation chamber, we need to perform one piranha cleaning to your Ca and Ca2. This is the chamber of the oxidation furnace. Since we mainly use the wet oxidation method, the left side of the chamber is the device for water vapor evaporation. First, we need to turn on the furnace. Turn on the power controller switches. Upper switch, equipment power switch. Middle switch, heater power switch. After turning on the power, the display screen will light up. The upper number shows the current furnace temperature, and the lower number shows the set temperature. Here shows the steps of the oxidation process. Check the volume of nitrogen and oxygen used for oxidation. The oxygen, nitrogen tank are stored outside the lab. Now we begin oxidation. Simultaneously press buttons 3/4 to start the oxidation process. Open the nitrogen valve 2 on the gas controller and adjust the nitrogen flow to 0.8 to fill the oxidation chamber with nitrogen, preventing premature oxidation and ensuring precise control of the oxide layer thickness. Later, when the temperature reaches 400 degrees centigrade, check the nitrogen flow. If it drops, readjust it to 0.8. Waiting for the temperature to reach 400 degrees, approx 80 minutes. Place the clean silicon wafers on the holder and insert them into the oxidation chamber. Use heat-resistant gloves as the chamber temperature is 400 degrees centigrade. Open the chamber to insert the wafer. Carefully place the wafer in the nozzle. To ensure that the wafer is placed in the middle of the chamber, We use a quartz rod to push the wafer in and align the adhesive strip with the mouth of the tube. The multi-layer quartz shelf is then placed in the chamber, aligned with the heated part of the oxidation furnace. Close the chamber with a quartz cover. Waiting for the temperature to reach 800 degrees Celsius, approx. 80 minutes. When the temperature reaches 800 degrees centigrade, check the water level in the flask. If insufficient, add the water to the black mark. Pour water into the beaker and funnel, making sure the water level does not exceed the black mark. Turn on the heat controller and set the temperature to about 120 degrees centigrade. Waiting for the temperature to reach 1000 degrees Celsius, approx. 70 minutes. Okay, now the program temperature has now reached 1000 degrees Celsius. Close the nitrogen valve too and set the nitrogen float to 0. Turn the valves 3 and valve 4 connected to the oxygen pipeline. Close the flask cap. Adjust the oxygen float to 0.8. Note: do not close the flask cap before introducing oxygen to avoid explosion due to high pressure. If dry oxidation, no need to heat the water vapor. And valve 1 is directly turned on to begin oxidation. Maintain at 1000 degrees Celsius for oxidation for about 40 minutes. Oxide layer thickness about 400 nanometers. After oxidation is complete, set the oxygen float to 0. Close the oxygen valve 3 and valve 4. Open the flask cap. Adjust the heater temperature control knob to 0 and turn off the heater power. Make sure the flask cap is open before turning off the heater. Open the nitrogen valve too and adjust the nitrogen flow to 0.8. Wait for the machine to cool down to 400 degrees Celsius, around 2 hours later. When the temperature slowly drops to 400 degrees centigrade, remove the sample. Follow the same steps as loading the sample and store the oxidized silicon wafer in a box. Set the nitrogen float to 0. Close the nitrogen valve too. And turn off the oxidation furnace heater and power switch.